Based on historical data, the manager believes that 31% of the company's orders come from first-time customers. So they're claiming that the true proportion of customers that are first-time customers is equal to 31% or 0.31. A random sample of 227 orders will be used to estimate the proportion of first-time customers. What is the probability that the sample proportion is between 0.22 and 0.35? So we're wanting to know the probability that that p hat, that sample proportion, is between 0.22 and 0.35. So first of all, we have to recognize that we're taking a sample greater than 1, and therefore our standard deviation of this sampling distribution is going to need to be calculated. Typically, that standard deviation calculation involves the following. We call it sigma sub p hat. We take the true proportion of orders that are first-time customers, times 1 minus that true proportion, and we divide by n and take the square root. So in our case, our true proportion they claim is 0.31. 1 minus 0.31 would be 0.69, and our sample size was equivalent to 227 orders. And we get a standard deviation of 0.2763. Now I'm guessing that here in this application that you use to enter your responses, we probably don't want to round that answer, but rather use that exact value, because I noticed the note says to carry 4 digits after the decimal point when you calculate your z values. So to calculate our z values, we're going to compare our sample proportion, and there are 2 of them in this case, to the true population proportion, and then we're going to divide by that standard deviation formula we were just looking at. So for the lower end of this interval, we said, what is the probability? It's between 0.22 and 0.35. So our lower p hat is 0.22. And they claimed that the true proportion was equal to 0.31. And then, of course, we're going to divide by that value that we just had calculated a moment ago. So that's our 0.31 times our 1 minus 0.31 divided by 227, our sample size, and then square rooted. And this will give us our first z-score. So I'll take 0.22 minus 0.31 and get an answer, and then divide by the square root of 0.31 times 0.69 divided by 227. And if I carry 4 digits after the decimal point, in this case that would be negative 2.9319. So basically that 22% is almost 3 standard deviations below the true proportion of 31%. Well, now we have to find the z-score for the upper end of this boundary, which was the 35%. So we're going to take 0.35 minus the true proportion of 0.31, and we're going to divide by that same standard deviation calculation that we did before. And in this case, we'll get a a z-score equal to 1.3031. So this value of 35% is not as far away from the true proportion of 31%. It's only about 1.3 standard deviations from the true proportion. So now to get the probability, we're going to use our calculator and its normal CDF command. where we have to give the lower boundary, which of course would be the smaller of the two scores, negative 2.9319. The upper boundary, which would be the larger of the two scores, 1.3031. And then the mean, which will be the 0.31, the true proportion. And then our standard error of the mean, which is our value of, I apologize, our mean isn't 0.31. We're using our z-scores here. So whenever you're finding the area under the normal curve and your lower and upper boundary are z-scores, then your mean is 0 and your standard deviation is 1. And in this case, we get an area of 0.9020, or a probability of 0.9020. So basically, if the true proportion of orders that are first-time orders is 31%, then in a sample of 227 orders, there's about a 90% chance that the proportion of orders that are first time would be between 22% and 31%.